So I played a little bit around with the white balance of the LED to get the right colors that I like by changing the resistors. So if it was a little too blue, I added more resistance on the blue. If it was a little too green, I added more resistance on the green. Ended up with resistors of 470 ohms for each of the blue and green, and then 150 ohms for the red LED, for the RGB LED. And you can see the pictures here of some of the colors that I got with the new resistance values. So let's do a little bit of a review. We're going to start building the 8 LED display, or persistence of vision, or color wand. There are many names, but basically we're going to use 8 LEDs in an Arduino to display a picture. So let's do a little bit of review. Let's think about a simple circuit LED. And we can think about the Arduino controlled LED just like a single circuit. So the Arduino acts as the power supply and as the switch, but mostly we like to think about it as a switch. So we're using the Arduino to turn things on and off by opening and closing that switch. We have a resistor so that we don't burn out our LED, and then as we close the switch, current flows through the circuit, the LED turns on, open the switch, and then it turns off. So we can compare that to what an Arduino circuit looks like. The Arduino is taking the place of our power supply and our switch. So the code is what opens and closes the switch to turn off and turn on the LED, and so turn it on and off. Before we get started in our project, we've up till now just been doing 1 or 2 LEDs. For this project, we're going to be doing 8 LEDs, so we need to sort of see the schematic, the drawing, so that we know what we're doing. This is our Arduino schematic, and here these little tags show where we have connections. So red, anywhere you see red over here, that means that red is connected to 9, digital 9, green and blue to 10 and 11. And then each of the common common cathodes of the RGB LED, each of those is connected to its own separate Arduino pin. And then we have resistors before each one of the colors, red, green, and blue, for the RGB LED. So let's take a look at what one would look like. So here I have my little 1 LED, and I've connected the red, green, and blue pins on the LED through resistors to the pins on the Arduino that are going to drive red, green, and blue, and then connected its common cathode to the digital pin that's going to allow current to flow from these color pins through the resistor, through the LED, and then to a low state or a ground state in each of these pins. So that's how we're going to control the colors and each LED, and now we just need to make 8 of these. So before we kind of were not very careful with where we placed the LED, now we've got to fit 8 of them on this breadboard, so we've got to be a little bit more careful. So I'm going to show you how we do that. So now it's time to wire up the circuit for all of the 8 LEDs, and we have to be a little careful about space so that we can fit all 8 LEDs on the board. So what I'm using is, our regular RGB LED, and I'm going to connect it in such a way. There are lots of ways that you can connect up this circuit, but I'm going to connect this one in such a way that it'll be easy for us to look at it once it's all hooked up and tell what's going on, whether or not we've made a mistake. So here's the LED with the common pin, and that's red, green, and blue. I'm going to put a common pin on one side of the breadboard, and I'm going to put red, green, and blue on the other side. And then I'm going to use these rails along the side in order to be able to hook all the reds together, greens together, blues together, respectively. So we'll hook up the first one and then copy that exactly. So I'm going to put this LED over here. I'm going to hook up the common pin on this left-hand side, and then the red, green, and blue on the other side. Now I'm going to move the blue one just one space over from the middle so that I can hook its resistor up on the other side. Since I only have two rails over here, I'm going to use red and green over here and blue over here. So that'll give me a little space for the resistor to cross over. I could put this so that the blue one, bend the blue wire so that it is over on this side, but then it's harder to tell which direction the LED is facing. So once you get these kind of positioned in the holes that you want to put them in and sort of gently push down. Alright, and there we've got the first one in, and then we'll go ahead and hook up the resistors. So this is red and green and blue, and this is common. So the red resistor, the red pin gets hooked up to the 150 ohm resistor. So I'll go ahead and put that one in. Actually, I want to use that side. And I've already pre-cut these resistors to sit nice and flat onto the breadboard so that nothing hooks them and pulls them out. And then I'll use the 270 ohm resistor, or sorry, 470 ohm resistor for the green. So that hooks to red, that hooks to green. And then the blue I've got to use on the other side. And I cut these resistors a little bit too short, so I've got to use a little bit of a jumper wire, so you'll see that in a second. So there's the 470 for the blue, and then I'm going to use this jumper wire to get it over into this rail here. So I'm going to go ahead and wire up the rest of the circuit, and it's just going to be exactly like this. And then we'll connect red, green, and blue to the pins that we need, and then the common pins to the pins that we need here. Okay, so now my circuit's all wired up, and all I need to do is just connect this to the Arduino board. And I'll connect red to pin 9. Green to pin 10. And blue to pin 11, just like we did before. And then all I have to do is connect up the common pins to these digital pins. There, and we're done and ready to start programming the flashing lights.